Okay, this is Dr. Polig, and we are back at chapter 12, Geometric Optics, page 421, and I'm going to go over briefly questions 7, 8, 9, and 10. Question 7 says, I have an index of refraction of substance A, which is 75% of substance B. So I have an index of refraction of A that is less than the index of refraction of B. So because it said that the index of refraction of A was equal to 75% that of substance B. Question is, in which substance will light travel with the greatest speed? Well, we know that the index of refraction is defined as the speed of light c over the velocity of light that's in that substance. Speed of light, remember, is 3.0 times 10 to the 8th meters per second. So we do a little bit of algebra, and the velocity of light in a particular glass, let's say, is equal to the speed of light divided by the index of refraction. So if the index of say glass A is less than glass B, we can see that that would mean that the velocity in A would be greater than the velocity in B. Since speed of light over A, the index of for A is smaller than the index of B. If this number is smaller, then that means that the ratio is greater. Okay, so we'll have higher velocity in substance B. And question 8, which substance will most likely have the higher density for light, for visible light, the higher the index of refraction, the higher the density most of the time. So since the index of refraction for B was higher, that means that the density, in general, the density of B would be greater than the density of A. Okay. Question number 9. When a photographer is taking a picture and does not use autofocus, they manually turn the cylinder around a lens. This focuses the image onto the film. What is a photographer doing when you adjust the focus on the camera? Imagine you have a simple camera. Let's say it's a pinhole camera, or not a pin, but something similar to a pinhole camera, where essentially you have a box, just a simple box. Oops. You have a lens here, so a simple convex lens, and your film is right in the back of the box. So the light comes in and it's focused onto the film. Okay, and as you can see, if you move the lens back and forth, you'll be able to adjust the focus back and forth. So essentially, when you adjust manually the focus of a camera, you are adjusting this lens back and forth. Question number 10. How does a human eye keep the image of an object it is viewing focused at the same place, even when the object moves? Well, the eye is a very sophisticated lens of sorts. So um, the light comes in and it's focused in the eye. This is the eyeball, down toward the back of the eye, we know. And you have muscles around the eye that essentially squeeze the eye down. Squeeze the eye or relax the eye down. So essentially what's happening is when you squeeze your eye muscle, the whole eyeball shape changes. And so so you're warping, if you will, the shape of your eye and the shape of this lens too. So essentially, you're doing something similar to manual focus of a camera. Well, that's very briefly the answer for question 7, 8, 9, 10 on page 421.